Hi all, I'm Shubh Pahava and I'm with my research partner Adarsh Kannan. We're both chemical engineering majors and are rising juniors. For summer scholars, we worked on the analysis of ternary systems at various isotherms. In the third year of the chemical engineering major, students have to take a lab course known as KEG 345 or Junior Lab. A new isothermal experiment was designed for this lab recently, so various mixtures needed to be tested in order to find out feasible ternary systems that fit the experimental constraints and were safe to use. Hence, our objective was to study different ternary systems that satisfy the experimental constraints for this new experiment.
Initially, the infinite dilution activity coefficient for each of the binaries was computed using the UNIFAC method which is available on the Aspen Plus software. The activity coefficients at the remaining compositions was computed using the Van Laar model, while the vapor pressure correlations was computed using the Antoine equation. This was used to model the excess Gibbs free energy, which was then used to model the excess enthalpy, excess entropy, and Gibbs free energy of mixing. Finally, the ternary behavior was modeled using the MATLAB programming language.
Initially, we had to study binary systems and compute different thermodynamic properties. This here is an example of the same. Here, y-x plots for two different binary systems are shown. The intersection in these y-x plots with the 45-degree line indicates the presence of azeotropes in the system at different isotherms that were examined in the 20 to 100 degrees Celsius temperature range.
Now we move on to the plots of delta G mixing as a function of composition. The plot on the left indicates negative curvature, thus implying stability and no indication of liquid-liquid equilibrium. On the other hand, the plot on the right shows positive curvature between the compositions of 0.2 to 0.6 and between the isotherms of 20 to 50 degrees, thus indicating instability and liquid-liquid separation. Finally, we move on to the ternary diagrams of two different systems shown below. On the left-hand side, the ternary diagram has two pressure extrema, one on the left and one on the right, thus indicating the presence of two binary azeotropes in this system. On the other hand, the system on the right-hand side only has one such extrema, indicating the presence of one binary azeotrope. Furthermore, all the curves of the pressure contour seem to move away from the left-hand side. This indicates the presence of liquid-liquid equilibrium in this system.
For the new isothermal VLE experiment, it was really important to beta test and find out what systems would satisfy the experimental constraints. To conclude, various systems were found to be suitable for the new experiment. Most systems showed a desirable VLE behavior and some systems with extreme non-ideality showed LLE behavior. Based on the lab objectives, the LLE behavior may or may not be desirable. Hence, based on the research done, a database of feasible ternary systems was created for the experiment. To put it all together, here's our research poster. Thank you.